Java developers are used to optimizing their code for particular platforms. The coding techniques that work for one platform might not be the best for another platform. Optimizing your code can help improve the performance and memory usage of your app. Now, you might not need to optimize, and in fact, many developers feel that you should only do these optimizations if you detect that there are problems with your app. These are sometimes called micro-optimizations. In some environments, making the kinds of code changes I'm going to describe here might not result in observable improvement. But if your app is having performance issues, these are some of the things you can look at to improve the situation. All of the suggestions I'm going to make can be summarized in a couple of recommendations. Don't do work that you don't need to do, and don't allocate memory if you can avoid it. All of these optimization suggestions are driven by the reality that a mobile device doesn't have the same amount of memory or processing power that, say, a desktop computer might. And so you're working in a constrained environment. And so here are some ideas that you can try out with your own Java code. First of all, avoid creating unnecessary Java objects. Every Java object that you create consumes memory on the device. If you generate a whole bunch of objects, they're going to take up a whole bunch of memory. And when you're working in a low memory condition on a mobile device, it can trigger the garbage collector, a process that goes through and destroys objects that are dereferenced by the rest of the application. The garbage collectors in the Dalvik and Art runtimes work slightly differently. Art's garbage collector is significantly faster and leads to less stuttering and pauses than the old garbage collector. But regardless of which kind of device or which version of Android you're running on, avoiding the garbage collector completely can improve performance. It's up to the operating system and the app framework to decide when it's going to run the garbage collection process. You don't have control over it as the developer. So the best thing you can do is reduce the amount of memory you're using in the first place. Here's a really simple example of avoiding adding an object that you really don't need. Here's some code that creates an instance of the Java String Builder class, a class that's used to append string values together to create larger strings. On the next line, I'm creating a string called tempString, and I'm getting its value by calling it object's getHello method. Then I'm appending that value to the builder object. It turns out that that intermediate object that I've named tempString isn't needed, and I can optimize the code by returning the value directly from the getHello method to the append method of the string builder object. A string in Java is immutable, and as soon as you assign it, a copy of the value is made. You now have two values, the version that was returned from getHello and the version that's temporarily stored in the string variable. By eliminating it, you've saved a tiny amount of memory. Do it 1,000 times, and you've saved that much more memory in your app. Another thing you can do to reduce memory usage is to prefer static methods over virtual or instance methods. If your method code doesn't need to access stateful objects, make the method static, and its invocation will be 15 to 20% faster and will use a bit less memory. You can also improve memory usage by setting static and final on constant values. This is a common practice in most Java code, but it's particularly effective in Android. And that's because when you create an instance field or an unseen class member, it generates and calls a class initializer method. You aren't programming it, but it's there and it's taking up resources. When you add the static and final keywords, that eliminates that overhead. And so whether you're dealing with integers or strings, if you're working with the value as a constant, make sure to include static and final, and your app will use a little bit less memory. You can also improve memory and performance by calling internal fields directly. It's very common in Java to create private fields and then public getter and setter methods. So in this code sample, I have two private fields called first name and last name. And then I have public getters for both methods. I then have a method called getFullName, which is accessing those two values. Notice I'm not calling getFirstName or getLastName from that method. Instead, I'm accessing the private fields directly, and that does improve memory. It reduces the need for the compiler to create intermediate methods during the compilation and packaging process. Now again, you might have seen this recommendation in other Java platforms, but in a constrained memory environment such as a mobile device, it's particularly important. It's also recommended that whenever possible, you use the for each looping syntax that looks like this. Now this does create an iterator in the background, but it has less overhead than the standard iterator interface. This bit of code is saying, loop through params, which could be an instance of the list interface or could be a simple array, and deal with each item in that list one at a time. You're not only reducing the amount of code you have to write, you're slightly reducing the amount of memory that's being consumed as the loop is set up and executed. Also, it's recommended that you use constant integers instead of enums. Now, I like enumerations in Java code. They're very elegant, and they let you define a certain set of standard values that can be used for a particular type. But it turns out that in Java they take up significant memory. Here's an example of an enumeration named things that defines two possible values, thing1 and thing2. This simple declaration takes up over 1,000 bytes. Now, if I change that and instead use constant integers, that is, variables marked with static and final, then I'm only using a fraction of that amount, 128 bytes total. So as much as I might like enumerations, if I'm really looking to fine-tune an application, I might decide not to use them, and I might decide to use simple constants instead. Now again, all of these recommendations are micro-optimizations. Each of them taken on its own will improve your app performance or memory handling only slightly. It's only when you implement these optimizations across the board in a large complex application that you might really see improvements. So, to make sure that the work you're doing is worthwhile, test, measure, and make sure that you know how your app is being affected. Test your performance before you make the code change, then test it again afterward. And you can use Android Studio's tools, its memory and CPU monitors, to see what's happening in your Android app as you run your before optimization and after optimization code and see how your app is improving. For more about optimizing Java code in your Android apps, see this webpage on the developer website.